how a gecko can run across a wall or hang upside down from a ceiling without falling? It may look like the gecko's feet are covered in some type of glue, but actually geckos do not produce a sticky liquid. Instead, their feet use a highly microscopic structure that allows them to grip surfaces. My name is Preston, and today I'm going to show you how engineers have studied this natural ability and used it to develop a technology known as Gecko Inspired Adhesive. Gecko Adhesive is an example of biomimicry, which is the process of studying nature and using its designs to solve human problems. In this case, engineers are copying the structure of gecko feet to create strong, reusable adhesives that do not require glue. To understand this technology, we first need to understand how a gecko's feet work. The bottoms of a gecko's toes contain rows of structures called lamellae. These structures are covered with millions of microscopic hairs called setae. Each seta branches into even smaller structures called spatulae. These structures are extremely small and allow the gecko's feet to make very close contact with the surface it is climbing. When the spatulae get close enough to a surface, weak molecular attractions called van der Waals forces develop between the gecko's foot and the surface. Each individual attraction is very weak. However, millions of these forces act at the same time, creating enough grip to support the gecko's body. The gecko can then release its foot by changing the angle of its toes, similar to peeling a piece of tape away from a surface. This is one of the most interesting parts of gecko adhesion. The gecko's foot can be strong when force is applied in one direction, but it can also release very quickly when the angle changes. This allows the gecko to run rapidly without its feet becoming permanently stuck. Engineers have attempted to recreate the system by manufacturing materials with thousands or millions of tiny artificial hairs. These hairs are usually made from flexible materials like silicone, polymers, or other synthetic materials. When the hairs press against the surface, they create a large contact area and produce an effect similar to a gecko's foot. Unlike regular tape, gecko-inspired adhesive does not depend on a sticky chemical. It's considered a dry adhesive, which means it can potentially be removed without leaving behind a sticky residue. It can also be reused multiple times because the adhesive does not dry out in the same way that glue or tape does. Gecko adhesive can be useful in different industries like robotics, manufacturing, and space exploration. Engineers are developing climbing robots right now that could inspect bridges, buildings, and aircraft. A robot using gecko-inspired pads could climb a vertical surface without needing suction cups, magnets, or permanent attachment points. This would be very useful on surfaces where magnets wouldn't work, like glass, plastic, or concrete. Climbing robots could also inspect areas that could be very dangerous for a person to reach. In the manufacturing world, gecko-inspired grippers would allow robotic systems to pick up delicate objects without damaging them. Traditional grippers would have to squeeze an object, while suction systems require air pressure and a tight seal. A dry gripper could lift an object by making contact with its surface. For example, it could potentially handle glass panels, electronic components, or other fragile materials. Because the gripping force can be controlled by changing the direction or angle of the contact, the robot could pick up an object, move it, and release it in a very controlled way. In the space world, gecko adhesive could have a potential use. This is because suction cups can't operate normally in the vacuum of space because there's no air pressure. Gecko-inspired gripping systems do not need air pressure, which makes them an option for robots or astronauts to use outside a spacecraft. Though it hasn't been done yet, it is a very viable possibility for the future. Now, there are several advantages to this technology. It can be reusable, it can work without glue or tape, it doesn't leave behind any residue, and it can attach and detach easily and quickly. It can also reduce the need for mechanical fasteners such as screws, bolts, clamps, or permanent adhesives in certain situations. However, gecko adhesive also has its limitations. Dust and dirt can reduce the amount of contact between the hairs and the surface. Water or any other liquid can interfere with the gripping ability of some designs. Even rough surfaces can be difficult because the structures may not be able to make enough contact. So, manufacturing these tiny structures can be difficult and expensive. The hairs have to be really small, flexible, and durable. If the hairs bend incorrectly, break, are contaminated in any way, the adhesive loses its strength. And in with these challenges, Gecko-inspired adhesive shows how nature can provide ideas for modern engineering. Geckos have developed an efficient climbing system without using glue, suction, or sharp claws. And by studying the structure of their feet, engineers can develop new gripping technologies that can be reusable, clean, and efficient. Gecko Inspired Adhesive uses microscopic structures to create a temporary attraction between an adhesive pad and a surface. The design is based on the setae and spatulae found on gecko feet, and although the technology still faces many challenges involving contamination, surface roughness, durability, and cost, it really does have the potential to improve robotic gripping, climbing systems, industrial handling, and many other products. Gecko adhesive is a strong example of biomimicry, and it shows how studying nature can really help engineers create more innovative and efficient technology. Thank you so much for listening. My name is Preston and we'll see you on the next episode.